Hi? Okay, you can hear me. So to start off, I'm going to be making some assumptions. I'm going to try to make it as not as boring as possible. So I'm assuming that you all use and love Git. I mean, there are other version control systems available, but let's face it, it's the most popular one for you. I'm assuming that you know Git flow. If you don't know what Git flow is, like, leave now, read up. It's going to make your life easier. I'm assuming that you are familiar with any sort of a CI tool, like Jenkins being probably the most popular because it's free and open source. But any sort will do. And a full disclosures, I'm an iOS developer, meaning I'm kind of a twisted in a way. So some of the things may not 100% apply to your environment. But let's establish the baseline here. So you have a product. Doesn't matter what it is. Like for my instance, it's an application. Like, go figure, a product has a code base, right? Then your code base has some tests to it. If you don't have tests in your application, you're more useful at your desk right now writing them than listening to me. Like, seriously, you don't want to be me in a situation that a couple of years back I didn't think much about testing. I was writing a very simple application that used a Facebook login, so I deployed that into App Store. And the very first comment I got is, why in my profile page my last name is Dupa? Because I didn't remove a placeholder, like working long hours, you get it. So you've configured your CI tool to actually build it, test it, right? Okay, so you've got something that provides you with the status of your job, how it's looking like, right? So how can you improve on that? By taking a step back. Like, you need to acknowledge that this is not a tool. It's not just a tool for you. Like, CI is an entire approach, like continuous integration and delivery. This is an approach you're making towards software development. This is the way you're going to be doing it across the organization. Meaning, this is the way your development is going to be working, your testing, your business, and your operations. And this is a commitment you're making towards quality, and you need to maintain that. And that means that you need to be able to communicate. If you don't have the ability to communicate in real time, you're increasing the cost. Because it is going to cost you. It's going to cost you time, it is going to cost you money to do. There are obviously some gains to it, but you need to make sure that it's happened. So let's take a look back at our baseline. I mean, we've got the code base, we've got the testing, and we've got the tool to run it, right? So what are we missing here? We're missing the repository. I mean, this is a critical component because you're not taking a look at a tool in itself, right? And you've got the hardware to consider. So if you want to do continuous delivery, then there's the question, what do you actually deliver? Like, we're doing Git flow, right? So what? Are we delivering master? You're doing the release branches, the develop branches? What's in actually releasable state for you? Like, who of you can tell that you've got a 100% of the time develop branch that actually builds for you? Or maybe should you deliver feature branches, like you do something, you're just deploying the capabilities without considering the entirety of a product. So I told you we're taking a step back. So we're taking a step back and we're rethinking the repository here without even going to the tool. You need to be able to enforce that your development branch, meaning the place you're delivering from, is in a stable and releasable way each step of the way. But then there's the question, like, how do you do that? And the first thing you're doing, you're taking the toys away from the development team. You can't do history rewrites for your repository because otherwise you'll not have any control over the product, not from the point of view of a continuous delivery. And I'm assuming you don't employ Jedi Masters, so not everybody knows how to use Force properly, so you're not allowing that. You're locking that. Each and every single Git server will allow you to block these things, and this is the first step you're taking. You're taking stuff away. Now, Each and every single of that service has a tool called a pull request, and I'm assuming that you're all using it. Like, it's a common practice. Now, by doing a pull request or a merge request, depends how you name it, you need to be able to enforce the deliverability. Meaning, you can't allow stuff that breaks stuff. So, at this point, you're not allowing anything into develop that didn't go through a pull request, so no odd commits on your local machine. And you're not allowing any pull request that didn't build. This is seriously a necessity for you right now. And while you're using a tool like a pull request, you can consider other stuff, like maybe you're leaning towards extreme software development, like you're doing pair programming, pair discussions, code reviews. So maybe that's a way of enforcing that actually a code review did take place for that. That's what that's what you have a pull request for, just use it. And that's even before you even started configuring your CI. But by doing so, you've got one problem, that basically your CI tool has become a guardian of your code base. So let's take a look at a typical pipeline for a more advanced job, like if you're doing it with all bells and whistles here. So you've got your preconditions, because you need to check out your repository. You need to download, build your dependencies. I mean, who of you doesn't have a dependency in your product, right? The obvious ones, like you're running the test, you're building stuff. Then the paper pushing starts. Like, if you're doing a constant delivery, then that means you need to keep track of what you actually delivered. And honestly, that can be really tricky. How do you version your application if you're delivering it on each and every single commit to develop? Like, how do you do that? That needs to be a conscious decision and a plan, because that version string needs to be unique each and every single time. Like, make sure of that. And while you're at it, you can just as easy generate a changelog, like extract something from Git, easy. You can generate documentation, providing that you actually do automated documentation generation, like, for instance, Apple doc-based Jazzy or Java, like most of the languages allow you to do the same thing. Now, the less obvious ones, like do your code analysis. You've got multiple tools to do any sort of a code analysis you can do. Like, probably everybody of you heard about static analysis of your code base. Do that while that, because this is a way you can actually gather the metrics for your code quality, and you can enforce it at this point via a pull request. If it doesn't pass a certain quality level, you're not allowing it in. You need to be able to deploy somewhere. Like, you're basically delivering a product, even if it's an internal micro delivery, you need to be able to deploy it somewhere. For instance, for an AS application, you're providing it to some sort of a service that allows the user to install it, use it. Like, or maybe you've got your own internal test environment. But that's the way you're doing it. And then, obviously, the mostly omitted part about it, and one of the most important ones, you need to be able to notify stuff. And that's, a notification isn't just did it pass, fail, but if you consider how complex the system gets, the notifications, like, you're spamming all over the place. So I'd like to give you a couple of hints of things to consider while we're doing this. So, I mean, the preconditions, the most obvious ones. If you've got a big repository, you need to rework it. Like, Git allows you to do that. There are some tools available. If you've got a large repository, and by a large repository, typically I mean everything exceeds 1 gigabyte, probably you've got a lot of binary stuff in it. Convert it to LFS. If your repository exceeds probably about 50 to 100 megabytes, you seriously need to shrink it down. Because if you don't do that, you're gonna start experiencing timeouts. Because your traffic, your network might get congested, you might have some connection issues, or just you have a broadcast on your switch in your network, and you're starting to get timeouts, and you're basically failing your builds just because you've timeouted a checkout, like before you even start. Make your repository as small as possible. Now, you've got dependencies, right? So I'm just guessing that you have a third-party dependency probably somewhere on GitHub. Yeah, you know, the thing about it is, if you're taking a conscious approach towards constant integration and delivery, you need to gain control over your entire code base. A dependency is a code base that you don't control if it's hosted somewhere on GitHub. Now, the thing about it is, speaking from experience, if you use something hosted on GitHub, these repositories have a tendency of either disappearing or changing the versioning, so suddenly something that built yesterday doesn't build today for you, or even something as funny as a connection quota. Not quite sure are you aware, but GitHub says something like there's a certain limit of how many connections can you make from a certain IP address to GitHub without getting a connection refusal for that day. It doesn't affect your development team because, let's face it, they don't build it that often. But if you consider a CI that does it tens or hundreds times a day, probably somewhere in the mid of the day, you're going to start failing your build because you weren't able to download your dependencies from GitHub. So going back, clone it, fork it, copy it over to a place you control, and if you don't need to rebuild it, cache it. Reduce the cost that it takes for you to actually build that stuff. Now, the obvious ones, like test and builds, that's what it's for, right? Yeah, but how many of you heard the Polish phrase "u mnie działa"? I mean, the bigger the team gets, the more members you have a problem with diverging environments. Your typical developers, even between them desks, might have different versions of different tool you use, and suddenly that stuff's working, building and testing on one environment, on one local machine, and it doesn't on another. Containerize it. For NIAS applications, you typically use Bundler because most of the build tools are based around Ruby, but that can be anything, any tool you can think of. Even if you need to do a virtual machine image just to reuse that component, you need to do that because more complex, if you increase stuff especially when you're relating to Jenkins, you've got multiple worker nodes. So we're talking multiple hosts that you need to manage and maintain the same environments for that stuff to be able to build. You're not going to be able. It's going to be too expensive for you. Containerize it and force your development team to develop within that container. So you've got a static environment each and every single time. Now, the obvious one, limit the execution time. I mean, if you've got the possibility of limiting the execution time by 10% for a job that takes roughly 20 minutes to do, so you're limiting just by 2 minutes, right? Not a biggie. But if you multiply that by the execution times each time you're running that job, you're basically increasing the throughput of your CI by 10%. Everything that doesn't need to get built, don't. If you can reuse stuff that doesn't need to get built for this run, reuse it. Use cache as much as possible. Now, as it comes to paper pushing, that's going to be a quick one and then just run through. The most typical way of versioning your releases would be using a git tag. So that's a nice solution to have. But you need to be wary about one thing. Make sure you're not rewriting these tags, right? If you automated it and you've given your CI the possibility of changing that tag, you might end up having the same version string pointing to multiple different commits, and suddenly you end up in a situation where multiple clients or business owners have different builds, and it doesn't work. Now you're in a communication struggle because it works for you and it doesn't work for somebody else. Make sure you're not rewriting tags, just multiply, so you need to take that into account when you're designing your tagging algorithm. Now, I mentioned code analysis, right? There's a lot of things you can analyze, apart from just the structures, code vulnerabilities, security analysis, up to performance issues, code smells. The one thing I'd caution you is the way you use test coverage. The minute you provide a number like our test coverage is 80% to your QA, you're going to be held to that. Don't shoot yourself in the foot. Make that number reasonable so that you don't need to upkeep something that doesn't correspond to reality. Just make sure. There are multiple tools available, open source, commercial, to do any sort of analysis. If you're not doing it right now, take a look into it and start doing it. This is the best way of maintaining not only the product but the code quality as well. So at least you can prove that you're doing something reasonable with your code. Now, I mentioned that notify gets complicated, right? Like, if you consider who do you need to notify about stuff happening, like you need to be able to notify the Git server about the build status, because you're using pull requests now to guard the stability of your critical branches. So you probably would like to notify the developer that caused the build to fail, not to point fingers. You probably would like to inform somebody about a new delivery. Now, the hardest part about it, if you're not creating an end application, but you're using a module, you're creating a framework or a microservice, and you probably would like to make sure that after building and testing it, you didn't break the whole system. So you'd probably want to create and launch builds for the upstream dependencies, another notification for you. And you'd probably monitoring your status somewhere. You need to be able to notify that as well. And that means you start using multiple plugins for the same job, and that typically takes half of your configuration. So make sure that you're using something stable. Now, just a couple of considerations here. You've done all what I've just told you. You are in a unique situation that you have the best quality of your product in your team. You're doing testing, analysis, everything. So now they ask you to, yeah, let's do the same for other projects in the company. Like, we need to increase quality. We've got some quotas to hit, like some metrics to generate. So sure, you've done the R&D. You can just replicate it. So you're adding projects. OK, so you're running out of resources. So you're just adding nodes. You're adding hosts to that stuff. You're extending your structure. Yeah, stop. You need to make sure that you're designing something that is scalable. Like, you need to treat your CI structure as your most important internal product. You don't take shortcuts. You need to make sure that it's scalable, that you've got enough hardware throughput to even do this project, and that your system is high availability to the point that you don't cause a congestion. Because if your CI is the one that's allowing pull requests through, and it fails on you, you've blocked development in your company. And now you're going back to, rushing back to your Git configuration and trying to disable CI just so that developers can do their merges, because there's deadline, there are other sorts of things happening, and you've basically thrown your quality out the window. Design at the point when you're expanding, design your structure before you exceed it. And learn to say no. That's probably the most useful skill you're going to have at this point. If you're not ready for a new project, for a new edition, just say no until you're ready. Thank you.
Thank you, Paweł.